Right. Thanks for joining in. I'm Melvin from Spectrum Labs. My track is about how we use Terraform and DBT to manage our Snowflake DB. All right, some joke of the day. How many seconds is in a year? How many? Actually, it's 12. Yeah, January 2nd, February 2nd. Yeah, right, so all good, all good. So just a little bit of a background what Spectrum Labs is. We are a content moderation platform utilizing AI. So you can visit us on our website to learn more. All right, for today's agenda, I will talk about Snowflake admin basics, a bit of Terraform, our CICD with Terraform, and DBT intro and how we use actually DBT and CICD for the most part. All right, so for Snowflake, obviously we have a lot of things that we manage in Snowflake, right? If you don't know Snowflake, it's obviously a data warehouse, a SaaS type of data warehouse. And they have obviously the users, roles, tables, warehouse. Actually, a warehouse is what they call their, compute, some kind of a compute engine. The privileges, stored procedures, views, etc. Because they have a lot more on top of that, like tasks, stages and whatnot. So they have internal objects that they actually have in their system. Right. So one thing we are kind of when we are using kind of struggle when we are using Snowflake in terms of like managing a lot of things. Well, creating users is really annoying, right? You have to be in a specific security context, like in this case, a security admin to create the users. And this is a sample when you create users, right? So you have all those attributes and whatnot. And most of the thing that attaches to your SSO is basically your email, and you have to manage all the roles right from here. And then at some point you also need to grant role, right? So in this case, we're granting financial sheep to this user, right? So, and you have to manage all of those roles specifically if you want to limit their access, right? So this way of managing things, usually database admin does that. And in our case, in terms of like when we are starting, sometimes we provide these things temporarily to a user to access the system. So, to get them unblocked, basically they do their queries and whatnot. So they just, apply this directly on the, on the database. Once you created the user, right? What's next? Well, there's a lot of user management privileges that you need to handle, right? Like I said earlier, there's global privileges, user resource monitoring, because you allocate resources for your data and whatnot. Virtual warehouse for like when you're querying things. File format for like when you're reading from your data source and whatnot. This pipe stream and task privileges, these are specific to Snowflake. Like task is like cron job for Snowflake. All those treasure trove of a lot of network privileges that you need to handle, and how you actually set them and apply them to your users is kind of cumbersome, right? And confusing at most. So this is an example of what we do, like when we actually apply things for for one of our tables. Like for example, when we grant user to create a database and we grant that access to Odelia, one of our software engineer, we had to execute a lot of these commands, right? So in this case, I'm giving the schema public to this specific analyst. I give the role also to another another analyst role. I grant all the tables from that schema to Odelia, right? Grant all the other schema in the database to the same thing, right? So it's individually I grant all of those things for the user and role side by side, right? So I have the user here, I have roles here, and then combining all of those things and all of the privileges that I need to provide. Future schemas are what the Snowflake does for actually anything that you need to change in the future. For example, if you need to create, a table on that schema, those are really what they call futures. So anything that is created on top of what already had been created, so that role analysts can have access to those tables and schema. Those are really the future, what they call future, right? So a lot of these things are being handled by obviously by Snowflake, but you need to apply them individually in terms of like how to use use Snowflake in the future for your engineering and development and whatnot. So what do you think is the best way of handling this privileges? Well, in our case, we use a lot of roles, and obviously we piggyback on the Snowflake's RBAC methodology. So these are the default roles that when you sign up for Snowflake, that will be available to you. Org admin is internal to Snowflake. We don't see that. We don't have access to that, but they are part of their architecture. You can actually view them on here on the link below. But for what we can see, we have the account admin role, which is actually a combination of sysadmin and security admin. But the account admin role has the highest level of access to your warehouse. So you can do a lot of things with the account admin role. So even create a warehouse, create different size of warehouse where you run your workhorses and whatnot. So when you run your queries, you use your specific warehouse. Security admin is mostly we're creating users and managing users. And user admin, we don't really use this much, but sysadmin we do. So like most of the custom roles that we created is under sysadmin. So because if you are a user or a power user, most of the access is already there in the sysadmin, right? So you don't need an account admin. You only need account admin if you need to create a warehouse, for example. But sysadmin already provides a lot of things for you to do a lot of things. And like, running stored procedures, running your tasks, running your, Snowpipe if you are using streaming, anything with regards to Snowflake, or sorry, S3 that calls Snowflake, if you have Snowpipe, everything is inside the sysadmin. Public is the default, so that's the sudo role. So it's automatically granted for you unless you change it, right? So the default is actually public unless you apply or you have a default role, and then that's get overridden by whatever role you put in. And obviously the custom role. Custom role is really powerful. We can talk about it in the next slide here. So custom role is really interesting, right? So the way that Snowflake have it is actually like it's set up as like a hierarchy, right? So anything that you that gets applied, right? So for example, you create a privilege, and you on that privilege you assign it into the role, and then you assign a role on that role. that will be inherited by the role that you assign it to. So it's very good because then you can combine different roles in a one role, and then you apply that role to your user, right? So now you can have that set up hierarchy that's easily trackable, right? So you know what you assign to that user because you had the role that has the hierarchy of everything, right? So you can apply the role to the user, as mentioned here, and then you can apply a role to another role, which is really good and setting up the hierarchy. Basically, what we did is really use the default role. So most of our roles that we created in Spectrum is underneath the sysadmin role, like I mentioned earlier. So like for example, we have the platform engineers will have more broad power. So they have account admin permission. and they have that role. But some of the users, we apply, like for example, if you are really reading the database for just querying for report, then you will have the a read-only role for some of the database tables. So you cannot update the table and whatnot. But the software engineers, we have some power users that we created a role for them. And the hierarchy of the roles are really scalable. So I tested 500 in my previous job before joining Spectrum, and creating 500 roles is not that bad, and it's easily done. There's no issues with Snowflake with regards to that. So it's really scaling out in that sense. So I heard from some companies they are even using 1,000 roles. So, well, yeah, I think they can handle it. The only thing that we really need to be careful is obviously this circular role, right? So make sure that you don't create this, a circular role that that will cause a cycle. And obviously you cannot apply that. But now, if you reach this point, then you are in trouble, right? You know that there's something wrong in the hierarchy that you set up, in the structure that you provided in your infrastructure to actually handle this kind of access for your users. So yeah, and obviously Snowflake will not allow you to apply it, but at that point, now you need to fix whatever needs to be fixed, because then you need to make sure that your hierarchy is set up properly in this sense. All right, so this is the continuation of the role. So like I mentioned earlier, as you can see here, the structure, the custom role is mostly under sysadmin. This is how we define, and I can show you how we did it in our code later on. But providing the best example, the best practices here is that, obviously use the least privilege principle. Always, if you have a user that's coming on board, make sure that you give access to only the things that they need access for. So for example, if they only need the read-only, then just provide read-only. If they need more access, then you provide it incrementally based on what they need. Obviously, a privilege needs to be remembered for audit, so needs to be written somewhere. In the past, when we have a database administrator, he has a big notes of a documentation where he puts everything on there. So obviously, it's better to put it in a group access. So group access is really now becoming the role, right? So your role is going to be your group, and if you provide that to your, if you're mapping into your company structure, it will be easier to to assign, because when somebody joins on that team and you can give them that group access, it's already provided automatically for them. Temporary roles are good for your project-based types of roles, and obviously the next part is really ensure that your most of the roles that you will create will be under sysadmin. All right. Aside from the roles, obviously, there's a lot of things that need to be handled. So, like again, I mentioned earlier, the warehouses, the database, schema, tables, views, functions, etc. They need to be handled in such a way that that can be tracked back. What were the changes, and what was done, what caused that change, and why we did it, right? So, from my previous experience, I want to address these issues because as a data engineer, as part of the DevOps team and data, mostly it's hard when we actually provide some access to try things out, to unblock them, but then we need to apply it everywhere, right? So for the development environment, it's okay that we need to change things in that side, but when now we need to apply that in production, we need to be consistent in that manner, right? So I need this is the things that I experience that we need to now make sure that we don't screw things up in production. So how do we? So this is the questions that I always have in my mind. So like, how do we handle users in general? Like how the roles are applied, and then how can I remove temporary access if I need to? Well, the other thing is auditing, right? So for SOC compliant and all those things that we are going to apply in the future, for if we need to, get some funding for our initiative, then obviously we need to make sure that we are compliant, and auditing is a big part of that. And most of the time, those are written somewhere, right? So for startup, sometimes you write it somewhere and then you forget about it. But this audit, it's going to be a big mess if if you don't have that somewhere written, right? So, and obviously automating this, right? So how do we empower engineers to actually, okay, if you need something, you know where you need to change the code, you know where it is, and just change the code there and let other engineers see, or even the platform team to see what's the change actually before we actually push it into our different environment. Right. So, all right. So in that case, we actually have Terraform handle that for us. Just a very basic of Terraform. Obviously, it's open source. Well, it's actually IIC, right? So infrastructure as a code. But they have the cloud solution by a Terraform Cloud. I don't know if you guys use Terraform Cloud, but it's good to actually managing state. But on our side, we manage the state is being managed in S3. Good thing about that is they have multiple product providers, and we create multiple reusable components by a module. For our solution that we have, we are using the Terraform provider. The old, this is the Chan Zuckerberg Snowflake is actually the initiative before. It was renamed because it's getting used a lot now. So, and then we apply those changes via Circle CI. So let me show you what we have here. So this is our Terraform code. We have all the users are kind of separated based on what I mentioned earlier. So we had, this is kind of a module, but we actually separated it so that we can run it separately in a different pipeline. So you can see here, we have a Spectrum sysadmin role. And then all the users are actually running this resource, right? So we have different grants that we apply for all the users that needs that type of role. We also have this is what I mentioned about the analyst role that's really needing small access to the database, or a limited access to the database. We have this analyst admin for it's like a power user to us. And we are keeping on adding a little bit more on the roles and the grants here. So basically the users that I mentioned earlier that's annoying is actually here, right? It's it's designed as like a module where we have a variable of all the users that we need to actually that we need to get applied for. For example, here are the actual users that we have, and this is what we are using in our pipeline. So like, for example, Aaron and Josh are obviously the admins, so they have the sysadmin users here. We have the platform engineering, myself and some of the platform engineers, the analyst users here. So everything is kind of the same setup, and it's set up like a modular, right? So when we run it, it's like this. Well, before I go there, let me show you the other Snowflake data objects that we handle. So these are the modules that we have. So for example, the full warehouse grant, we have it set up here. Every time we actually, for example, if we need to increase access to our if we need to create a new warehouse, we actually put it here and run it as a module, right? So we made it a modules because every now and then we need to provide that access to that warehouse to different users. So we also have like database grants here, all the stored procedures we have here, database and whatnot, all the roles that we provide, stages basically when you actually load from when you're ingesting data into Snowflake, you always put it in a stage, and then that's actually what this is, right? So we stage the data, all the grants, everything is in the code basically. Users and all those things, warehouses, yeah. So everything is in the code, and you can see here this is our warehouse, right? So how we run them, and in that sense, we use circle CI pipelines, right? This is how we control the environment, so we can audit it. So anything that gets applied manually will be overridden and get deleted, because those are not supposed to be there, right? So only for those that are really things that we need to make sure that the users are for their quick fix, or so that to unblock them, we apply them directly. But obviously, we need to remove them afterwards, and this is how we control our pipeline. So again, this is our Circle CI pipeline. Oops. You can see here we have a build test, and this is how we apply. We have approval. Make sure that we don't that we know that we were changing. You can see here in the plan what was changed, what needs to be. Let me enlarge it a little bit. What needs to be changed, what are changing, what net gets applied. And we always look at, for us platform engineers, we always look at the part here. What is the plan changes, the additional, and what are being destroyed. We're very careful not to destroy a lot of things. But this kind of destroy is really more of a replace, so we're fine with that. So we mostly approve that and let it flow towards the applying into the actual environment. So yeah, so once we approval goes applied, and then in dev, and then applied and also make sure that they are consistent with our prod, and we apply them in prod. So yeah, so that's how we manage our data objects in Snowflake. So tying it all together, this is how we actually applied it. So we have account. We have account admin role that we applied to Snowflake. We just created this user with key pairs, and then let's Circle CI run those. Very easy. So that's Terraform side. And okay, what's next? Who does this, right? Who remembers this, right? You have multiple tabs on the top. It gets applied in Snowflake. I'm guilty of that, actually, myself. And how about this? All the SQL that gets run and gets applied on creating your views and whatnot. I'm also guilty of that, and then forgetting about it and putting it in in the database and forget about it. And creating the cubes like this. How about this, right? Data engineers' job to actually create pipelines, the old way of doing things, right? We have, a lot of ETL, basically. This is obviously a newer version of ETL, right? But still kind of dated, right? So data engineers will work mostly on this, and your analyst engineers will be waiting on the other side. So actually, when this is done. Meanwhile, there's another way of doing these things. We have DBT, right? So DBT actually is, I'm very passionate about DBT, to be honest. I did introduce it in Spectrum, and I did pilot it in one of our projects there, because I'm convinced about the technology, and that it will actually help us in our things that we're going to do in the future. So, well, this is really empowering our analytics, and this is one of the the things that I got from the DBT's Slack channel, right? So analytics engineering is becoming real now, that you can empower them by using DBT, right? So you don't have to wait for data engineers. You don't have to do and you can actually do things more in a way that aligns to what software engineer does, or the software developer does. Like, for example, writing your SQL in a way that you can version them and put it in Git, right? So this is the current structure that the DBT provides, right? So they have this analytics engine engineering workflow. I'll just provide you some details here that you have this raw data, you can transform and develop, you can test that the data that you are going to that you're going to use, document that, and then deploy them, right? And these are the output of that engine. So the side here is like, this is the common structure of DBT. We have a DBT project YAML and all of the files needed to actually start your project. Profiles actually defines the environment. All right, why DBT? It has a very strong 36,000 user members. You can see here, I don't know if you can see it here at the bottom, it's like 35,000. But right now they are actually, if you look at here, they're around 36,000. So they're growing very, very rapidly. They have customizable macros. We actually use the macros ourselves. It's a natural fit for Snowflake, for the tooling, for the ETL, because it's a warehouse transformation tool. And like I said earlier, there's a lot of inclusions, like the tests. When you run tests, you can snapshot the data. You can there's some metrics about your data and everything. And for most part, I really like the CICD potential, because that's how we actually apply things. It's like, when I look at it, it's like, oh, this is actually Terraform for your data. When I told the team, like, I did run it a lot of times, and it's actually part of our workflow right now. So it's also a way to actually augment your DAG. So like, if you have Airflow, like one of my former colleagues, they put it in Airflow, and they run it side by side with their analytics, with their, I think they're using BigQuery and Looker. So they have that running on the side. So like I said earlier, it helps empowering your engineer. So the data engineer can still work on the things that they're passionate about, like, building the pipelines, the orchestration, building the infrastructure behind those orchestration, managing the warehouse and whatnot. But the analytics engineers can do more now, right? So they can apply the best practices. They can clean the data on their own. They can transform the data without needing help from the data engineers. They can control and do the documentation themselves. They understand what the metrics are. Anything that regards to how to actually explain the data to your stakeholders is handled now by analytics engineer by working on using DBT. This is a really bit of a concept how it's actually working. So really, you have this kind of tables, right? And if you can see here, it's templated. It's like Jinja. It's actually using Jinja. It's just like similar to what Terraform does. You can pass variables in, and then it actually gets applied when you run DBT, right? They have this concepts here about what the models are, what materialization are, sources, seeds, and all those stuffs that I mentioned earlier. But yeah, this is how you actually create your kind of a SQL. So you do the transform on the fly, right? So when you actually do the select here at the bottom, it actually combines this thing and does the transform for you. All right, so this is another set of the concepts. I can show you why we are doing that later in the code. But the other good thing about here is actually I was challenged by Bryce the other day about, okay, I need something to be done. How can we actually do this way to actually automate the creation of the, for clients, the tables, because we had a service that's running that does that right now to actually ingest the data. So I was actually trying to things out and did something using the custom what do you call that? I forget. The custom running on the DBT, custom code that runs on the DBT. So this is one part that can handle that. So which is really good. So benefits of using DBT obviously is a templating engine. So for your SQL with Jinja, Source can be version via Git, as you guys know. No more mysterious metric changing, as we know. Debugging is easier because it's actually you can trace back to the source. Custom adapter is really good. So if we need to change the behavior of Snowflake, for example, we can create that custom adapters. The custom templates is actually good also. This is what I was mentioning earlier. We are using this and easily generate the documentation for your models. This is actually explaining what the metrics are, where the tables are. It's easier for you for your data analysts to find where things are and how they get created. All right. So from there, let me show you the code that we use to actually do DBT. So we have a DBT Snowflake here. For the most part, we have, the things. I'll tell the details about this, and I'll be back about why we did it this way, right? So we have a regression test that we run that gets stored in our staging, or actually our S3 bucket. And this part here are the custom templates, right? So that I'll provide detail about that in later on. But if you can see here, these are our select queries, right? So you can see we had the variable that being passed in, and there's obviously a it condition because there's a few things that change in our data that we need to handle. And this thing here, is a placeholder for Snowflake. So Snowflake doesn't have a concept of the actual columns when you're actually ingesting them. So I had to make it like this and then actually pass the actual name so that the downstream table or the query, the job, the downstream job can actually relate to the actual column instead of a number, right? So, but this here is actually a nomenclature of Snowflake, so I don't have a handle about that. So that's why it's like that. But anyway, so this is, we have a if condition here to actually control what gets run and what gets transformed, right? So this part here is our kind of our custom templates. The same applies here. As you can see here, we have same structure, same everywhere. This is actually when we have the structure here is it's raw. So this is actually exactly what's in our S3. We just pull it in and put it in our Snowflake table. And we also have incremental. So this is actually a good way of doing incremental, right? So we had the materialized view here, the incremental strategy. Let me go to the right here. Is we use a unique key of the timestamp, and this is actually kind of a drop and reload type of thing. So we delete the data and we insert it, and it's actually syncing in all those schemas. So this is how you actually do it in Snowflake. In DBT, where you actually incrementally insert data and whatnot, right? So this is how we transform on the fly. Those things are actually defined on the models here. So this is actually needed to actually define what they are. The test actually tells you, okay, all right, those data that I'm looking at, the client should not be null, right? So I can run tests before actually inserting the record to our database tables. Yeah, so this is just showing you what our external templates look like. So the variables earlier on the top is actually defined here, right? So we are using the adapter Snowflake. And for all the clients that we have, because we need to dynamically create the table if they're not there. But if it's there, we need to actually just use the table itself and then do the insert, update and insert, right? So I run a few things here, extrapolations and whatnot. And this is the actual, actually, let me show you here. It's calling the stage, like earlier, I mentioned earlier. We have temporary table for the stage data so that that the Snowflake will actually, from Snowflake, it will actually load from a specific S3 location, right? So it knows what the S3 location looks like, what the file format, and then you can inspect that data, load it temporarily, and it will actually look like this, right? So you can query it like that. So from there on, once the data is in the stage, you can now do the actual, is it a full refresh mode, or is it you need to drop the table and whatnot? So this is actually the one that creates and replaces the actual table in that sense. And then after that, if the table is created new, obviously we insert the records. Otherwise, we actually, this insert the records, insert the data. Otherwise, we just do the merge. So merge is actually the abstract way of writing into Snowflake. This right now works for us really good. I can show you where it runs on a Snowflake later on on Circle CI and what it looks like in Snowflake. But this is just to give the idea why we did things like that. This is the use case that we have, right? We need to load our regression into Snowflake. So we have the data here in S3. The format is CSV. It's partitioned by date. So this is the requirements from the one of our customer, actually one of our user. She needs the data loaded for each customer, automatically loaded once the report is run, and incrementally for some of the reports that she needs, right? So we used, again, earlier, like I said, we used the DBT macro templates, Snowflake, all the direct transformation and whatnot, and incremental loading. We use the merge command from Snowflake. So, oops, sorry. This is our Circle CI pipeline. This is how we run the command, right? So the target is actually, in this case, dev. So this is the profile that I was referring earlier. And then we had the raw and the incremental. And then we also have a smoke test. And finally, this is how it looks like when we run it. We have the Manusa is actually our test regression for our some of the regression tests that we run. We run DBTs here. You can see here we are inserting data, same command that I mentioned earlier. How it end up looking at in Snowflake actually is like this. Sorry, it's kind of small here, but this is what each smoke test we have for each customer is here created for us. This is just a collection of everything. And then we have the raw data here as well, right? So raw and incremental. So this is like a snapshot of that specific run for that specific partition and the date. And the incremental is continuously, like you can backtrack in like a history that when we started running this. So yeah, that's how it looks like. It's good. So we are trying to hopefully adopt more of the DBT in the future because obviously it's becoming norm. But yeah, that's how we use the DBT right now. All right, I think I'm on top of the hour. Any questions? Thank you for listening in.
Sorry, really great, Melvin. I was just asking, what made you choose Snowflake as the platform that you wanted to build all of this testing infrastructure on top of?
Yeah, because most of our analytics are running on Snowflake. Our transactions are mostly in the Postgres database at the moment, and our analytics doesn't have access to Postgres. I think that's exactly right. Yeah, and also like all of our reporting engine and all our visualization is running on top of Snowflake, including for the customer. So this is easier for them to actually do their queries and whatnot. So yeah.
Do you actually end up sharing some of this data with your customers as well using Snowflake secure share capabilities?
It's actually we have some reports that are shared in the customers, right? We think via Looker, if I remember it right. Exactly, yeah.
my question is what makes you choose between copying into materialized view and view? You guys give your opinion on it and try to bring it together.
So the question is copying into versus.
Yeah, so I think inserting or bringing data in from AWS.
Yeah.
Have you evaluated between doing a generative view of AWS or creating a materialized view of it, or just do a direct copy into it?
Yeah, we did a direct copy. Well, from this project that I have, we did the direct copy because we want to look at the raw data first. We did not use the reason is actually we want to load the data locally. Oh, sorry, not locally, but in Snowflake, because we want to look at the raw data. But we did not really look at the other things with regards to creating the external table. I think you're talking about external table and whatnot, right? So yeah, we did not because we want to have that stored in our Snowflake. But I have no strong opinions which one to use which. It's more of like, is what your experience and what's your comfort level of using things. But I believe that's really more of like how because when you put the data in Snowflake, you are now on their kind of, I would say, apply on the constraints that you get that gets applied to your data, right? So if you have external table, it looks like everything is string. At least if you put it in your Snowflake, there's some conversion happening in between. Like for your numbers, it gets automatically converted into number, right? So if it's an external table, like when we had in using it via EMR before, everything's string, right? So it's really, it depends on what's your what you're liking. So
yeah, I had a question too. So when you showed DBT and you showed the Jinja templates inside that, so when would you use just Jinja templates? So the background to this is in Habu, we want to expose Jinja to the clients as well, so that instead of just writing SQLs, they could write Jinja templates directly, right?
Yeah.
So my question would be, do you think it is better to expose like a DBT kind of a shell to the user, or would you think that Jinja should be the correct use for that? Or what is the difference, would you say, between just using Jinja versus using DBT?
Yeah, that's a good point. We did in the past in my former job, we did use Jinja a lot also when we are writing a lot of SQL and whatnot. The good thing about DBT is obviously other things that can do for you, right? So like again, like the metrics, the snapshotting, all those things, and even the documentation. Actually, just doing the documentation, you can just do the like DBT doc serve, right? It will just run things for you, and then you can do, document your objects right there, right? Easily. So define on your models. But I think this is my opinion only. Is like because it's becoming the norm for like managing your way when you're actually running things with regards to analytics and building your queries and whatnot. I would say you use the DBT's functionality for that. I don't know if that's you answered the question.
Yeah, I think so. Yeah, and do you expose this to the clients as well, this DBT thing, or is it entirely just for the developers inside?
Mostly for the developers, analytics engineer. The actual result of it you can expose, but obviously your data analysts maybe can build their own, DBT source code and engine, and that can be exposed, right? So
yeah, sure, that makes sense. Thanks.
Yeah.
I have a slightly different question. I know the topic is on DBT and Snowflake, but I do understand Spectrum uses a lot of Spark. So have you used DBT with Spark? And
no, not yet. At some point maybe, but at the moment we don't have a need for it. But we have Argo workflow with Spark. Actually, later on we have that talk with Dave, so you can listen about that. But yeah, we haven't used it yet with Spark.
Hey, I'm just curious in cases where the transformations get very messy and you need to get data from a lot of data sources, and then each data source has dependency on a lot of different tables or goes into a lot of different tables, does DBT provide you the tools to kind of debug, understand what's going on, and kind of scale transformation through many data sources?
Of course, yes, they can, because you, like, again, they have a test, a way to do the test, so you can actually do that, and it will be now easier, right? Because the problem with analytics, obviously, sometimes you get the changing metrics, right? You don't know why did it change, and then you need to track back, like, oh, somebody made the calculation wrong, like, you know, when you ingest the data, the calculation is wrong. Like, for software engineers, it's easy to debug things because you know the code is the problem. But in engineering and data, sometimes the data itself is wrong. So managing these things makes it easier for you with the use of DBT and with especially the test part of their on their binary. It helps a lot debugging and whatnot. So actually, that's my main problem before. One of our user was complaining about why is the source that we have is not matching, and that's why I created this this if then else on the Jinja, because they did not match when she gave it to me. Like, when I look at the data, it's like, oh, it's not aligning because you are creating more columns on the right, and that's common, right? So like, instead of putting it in the middle, just put it in the very right so that we can actually handle it in that way. And that's this part here. So anytime you create, and that's actually the last, the last column that we added. But
Okay.
I think we're one more. Oh, yes. The custom, most of the things that you can do actually is handled by all of this SQL right here. So like I think I showed it here before. Yeah, here. You can create custom SQL, custom functions. It can be handled for you. So, you know, for what we are looking at right now, we separated all the database admin management using Terraform, and everything else that needs, you know, specific data transformation, the data itself that needs to be created, we are going to use DBT. I'm actually pushing the team to actually do that, and I'm hoping that we can actually start working with that in our reporting, in our analytics. And I think we are already on track on that. Some of our Looker type of reporting needs, I will be piloting using DBT, aside from what we have right now. So, all right, I think we are on the top of the hour. Thanks a lot, guys, for listening in.